The National Electrical Code, or NEC, does not explicitly provide an exception for switchgear heights that exceed the specified requirements in Section 240.24. However, there are two potential methods to address this issue. Firstly, engineer a platform or structure. Install a permanent or temporary platform or structure adjacent to the switchgear to provide safe access to the higher breakers. This platform must meet the requirements of NEC Section 110.16 for ladders and platforms, including a minimum width of 24 inches, suitable railings and toe boards, and a safe means of access and egress such as stairs or ladders. Secondly, use a rated portable platform. Utilize a portable platform that is specifically designed and rated for the weight and height of the breakers being accessed. The platform must be constructed of non-conductive material or have appropriate electrical insulation, provide stable and secure work surface, and have a handrail or guardrail for safety. A working platform is a raised or elevated surface that provides a safe and stable place for workers to access and work on electrical equipment. It can be permanent or portable, and may include railings, toe boards, and other safety features. Portable working platforms are specifically designed to be easy to transport and assemble, making them suitable for temporary use. They typically have a lightweight construction and foldable design for ease of storage and transportation. It is important to remember that while portable platforms can provide a flexible solution, they must still meet all applicable safety standards and be appropriately rated for the intended use. Ignoring height restrictions can have various implications for electrical installations. Firstly, safety hazards. Overreaching to access high-mounted circuit breakers increases the risk of falls and other injuries. Secondly, code violations. Installations that do not comply with NEC height requirements can result in failed inspections and fines. Thirdly, accessibility issues. Difficulty accessing circuit breakers can hinder maintenance and emergency operations. When selecting a platform, consider these factors. Firstly, height requirements. Choose a platform that provides adequate height to safely reach the breakers. Secondly, weight capacity. Ensure the platform can support the weight of the worker and any tools or equipment. Thirdly, stability. The platform must be stable and secure to prevent accidents. Fourthly, material. Opt for non-conductive materials or platforms with appropriate electrical insulation. Fifthly, portability. If frequent relocation is necessary, select a lightweight and easily transportable platform. Section 240.24 of the NEC covers the location of overcurrent devices in enclosures. Specifically, 240.24 addresses accessibility. Overcurrent devices must be readily accessible. This means they should be capable of being reached quickly for operation, renewal, or inspection, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. The intent is to ensure that qualified personnel can safely and easily operate and maintain the overcurrent devices. 240.24b focuses on the height of the overcurrent devices. The center of the grip of the operating handle of the switch or circuit breaker, when in its highest position, must not be more than 6 feet 7 inches or 2 meters above the floor or working platform, unless one of two conditions is met. Firstly, for busways, as described in 368.17c, the height limitations do not apply. Secondly, overcurrent devices installed in accordance with 240.24d are also exempt. 240.24c covers not located in bathrooms. Overcurrent devices are not permitted to be located in bathrooms of dwelling units, or guest rooms or guest suites of hotels or motels. 240.24d addresses overcurrent devices adjacent to utilization equipment. Overcurrent devices are allowed to be located adjacent to the utilization equipment that they supply, provided that the following conditions are met. Firstly, qualified persons only. Only qualified persons must be able to access the overcurrent devices. Secondly, continuous industrial processes. Conditions of maintenance and supervision ensure that only qualified persons service the installation, and the electrical system is designed to minimize unplanned interruptions of the process. Thirdly, documented switching procedures. Documented switching procedures are provided and maintained for the installation. This section recognizes that in certain industrial settings, having overcurrent devices directly accessible to the general public is not practical, and that qualified personnel are better equipped to handle the operation and maintenance of these devices. The general rule outlined in 240.24b, limiting the height of the operating handle to 6 feet 7 inches, is intended to ensure that overcurrent devices can be easily and safely operated by qualified personnel. The exceptions provided in 240.24d acknowledge that in certain industrial environments this height restriction may not be feasible or practical. In these cases, the code allows for overcurrent devices to be located in areas accessible only to qualified persons, provided that certain conditions are met to ensure safe and reliable operation. When dealing with circuit breaker heights exceeding NEC requirements, several potential solutions can be considered. Firstly, lowering the switchgear. If feasible, the entire switchgear assembly could be lowered to bring the circuit breakers within the permissible height. This may involve structural modifications and careful planning to ensure proper clearances and support. Secondly, using remote operators. Install remote operating mechanisms for the circuit breakers, allowing them to be controlled from a lower, more accessible location. This could involve installing actuators or other devices to remotely trip and reset the breakers. Thirdly, implementing a combination of solutions. Depending on the specific circumstances, a combination of the above approaches may be the most effective way to address the height issue while maintaining safety and code compliance. Remember, any modifications or changes to the electrical installation should be performed by qualified personnel and in accordance with all applicable codes and regulations. The NEC definition of readily accessible means capable of being reached quickly for operation, renewal, or inspections, without requiring those to whom ready access is requisite to climb over or remove obstacles or to resort to portable ladders, and so forth. Readily accessible implies a certain level of convenience and ease of access. The intent is to ensure that qualified personnel can quickly and safely operate or maintain the equipment without undue difficulty. This term is often used in conjunction with electrical equipment such as overcurrent devices, disconnecting means, and other components that may need to be accessed in the event of a fault or for routine maintenance. The NEC emphasizes the importance of providing a safe and accessible working space around electrical equipment. This includes ensuring adequate headroom, clearance distances, and access pathways. For example, NEC Section 110.26 specifies the minimum working space required in front of electrical equipment, taking into account the nominal voltage and condition of the installation. These requirements are designed to protect electricians and other qualified personnel from electrical hazards while they are working on or near energized equipment. The working space must be kept clear and unobstructed to allow for safe access and egress. Proper illumination is also essential to ensure that workers can see clearly and avoid potential hazards. In addition to the general working space requirements, the NEC also addresses specific accessibility requirements for certain types of equipment. For example, as previously discussed, overcurrent devices must be readily accessible, and their operating handles must not be located too high above the floor or working platform. Disconnecting means for motors and other equipment must also be readily accessible and located in sight from the equipment they serve. These requirements are intended to ensure that qualified personnel can quickly and easily energize equipment in the event of an emergency or for maintenance purposes. When assessing accessibility, it is important to consider the physical limitations of the personnel who will be working on the equipment. For example, if the equipment is located in a confined space or at an elevated height, it may be necessary to provide special access equipment such as ladders, platforms, or lifts. It is also important to consider the potential for obstructions or other hazards that could impede access to the equipment. In some cases, it may be necessary to relocate the equipment or modify the surrounding area to improve accessibility. The NEC provides guidance on the selection and installation of ladders, platforms, and other access equipment. For example, ladders used in electrical work must be non-conductive and must be inspected regularly to ensure that they are in good condition. Platforms must be designed to support the weight of the worker and any tools or equipment they may be carrying. It is important to follow the manufacturer's instructions for the safe use of access equipment. In summary, accessibility is a critical consideration in electrical installations. The NEC provides detailed requirements for working space, clearances, and access to electrical equipment to ensure the safety of qualified personnel. By following these requirements and considering the specific needs of the installation, it is possible to create a safe and accessible working environment for electrical workers. When dealing with situations where switchgear heights exceed the NEC requirements, it is crucial to prioritize safety and compliance. Here are some additional considerations and best practices. Firstly, conduct a thorough risk assessment. Before implementing any solutions, conduct a comprehensive risk assessment to identify potential hazards associated with the elevated equipment. This assessment should consider factors such as the height of the equipment, the frequency of access, the type of work being performed, and the qualifications of the personnel involved. Secondly, consult with qualified professionals. Engage qualified electrical engineers, safety professionals, and other experts to develop a safe and compliant solution. These professionals can help assess the situation, evaluate different options, and ensure that the chosen solution meets all applicable codes and standards. Thirdly, prioritize permanent solutions. Whenever possible, prioritize permanent solutions that address the underlying issue rather than relying on temporary fixes. For example, lowering the switchgear or installing remote operators may be more effective and safer in the long run than relying on portable platforms. Fourthly, implement comprehensive safety procedures. Develop and implement comprehensive safety procedures for working on or near the elevated equipment. These procedures should include requirements for personal protective equipment, fall protection, and lockout-tagout procedures. Fifthly, provide regular training. Provide regular training to all personnel who will be working on or near the elevated equipment. This training should cover the safe use of access equipment, fall protection measures, and emergency procedures. Sixthly, document all modifications. Thoroughly document all modifications made to the electrical installation, including the design, installation, and testing of any access platforms or remote operating mechanisms. This documentation should be kept readily available for future reference and inspection purposes. Seventhly, conduct regular inspections. Conduct regular inspections of the electrical installation and access equipment to ensure that they are in good condition and comply with all applicable codes and standards. Address any deficiencies promptly to prevent potential hazards. Eighthly, consider future maintenance. When selecting a solution, consider the long-term maintenance requirements of the equipment. Ensure that the chosen solution will allow for safe and easy access to the equipment for routine maintenance and repairs. Ninthly, obtain necessary permits. Obtain all necessary permits and approvals from the local electrical inspector or authority having jurisdiction before making any modifications to the electrical installation. Tenthly, communicate effectively. Communicate effectively with all stakeholders, including building owners, facility managers, and electrical workers about the changes being made to the electrical installation and the associated safety procedures. By following these best practices, it is possible to address situations where switchgear heights exceed NEC requirements in a safe and compliant manner. Remember, safety should always be the top priority when working with electrical equipment.